So please welcome Nawaf Aljehani, who's going to show us the exciting 3D capabilities. Nawaf?
Thank you, Sam. Hello, everyone. Today, I am excited to present the new 3D capabilities of ArcGIS using a stunning digital twin of Zurich in Switzerland, along with other applications of the platform. Zurich's digital twin model consists of multiple layers from various data sources. Let's explore a few. In the background, schematic buildings and trees consist of 3D objects layers from the city's open data portal. In the foreground, realistic 3D models are created using ArcGIS Reality and imagery captured by Wingtra drones. What's new in ArcGIS this year is the ability to work with 3D tiles meshes. These tiles can be hosted on ArcGIS Online or in an enterprise, making it easier to share the ArcGIS data within the ArcGIS system. Now, let's explore the interiors of this university building. The interiors are represented as extruded polygons provided by ETH University. This is where Albert Einstein studied. In fact, his locker is still there, and you can visit it. In addition to browsing 3D interior data, we can also integrate data from the design and construction industries into our scene. For example, this BIM data from Swiss Federal Railways and VBZ, the tram network operator. This allows us to adjust the mesh directly in the scene viewer, ensuring that the BIM elements are visible alongside the 3D models. In the context of construction and design verification, we can add point clouds, where we can add it to help us verify the accuracy of the as-built conditions against the design. While our digital representation of the city environment is impressive, it remains a static model. However, when we introduce time, the model comes alive. Using the new time slider in the scene viewer, we can explore how Zurich has developed over the last 7 centuries, revealing historical changes in the city's architecture. Looking to the future, we can simulate tree growth over the next 50 years. We can visualize how the landscape will change by utilizing attributes such as shape and size that defines how trees grow. Furthermore, we can use the line of sight tool to assess the visibility of proposed buildings near the lake over the next 50 years, noting how visibility decreases as trees grow. We can also create real-time simulations on the web in 3D. For instance, a custom JavaScript application using ArcGIS Velocity can display real-time data from temperature sensors and motion detectors in rooms. This shows how people move during emergencies, such as fire evacuations, which can be critical for training emergency responders and improving situation awareness. Now, let's examine 3 practical examples of how this digital twin can be applied. Educators can provide indoor and outdoor wayfinding for students and visitors. Users can input their starting and ending locations, and the app will generate a route based on their chosen mode of transportation. This route can be viewed in 3D, helping users anticipate elevation changes and potential obstacles. Let's explore other industries that will benefit from this technology. First, facility managers can also benefit from this technology. They can view their facilities within the context of the larger city environment. They can also search for specific assets in the 3D scene and see related information coming from external business systems. This is achieved through a JavaScript application that maintains a live connection to ServiceNow. For example, if the cost of an asset is updated in ServiceNow, it will automatically reflect that change in the 3D scene, demonstrating the power of real-time data integration. Second, urban planners can leverage ArcGIS Urban to plan proposed developments in the city. This includes assessing potential carbon emissions associated with the design. Now new, in the editing tools in ArcGIS Urban and the Scene Viewer, it allows users to set constraints. When a feature is added, such as a building, I can add a deflection angle of the next line segments and distances to the next point, greatly enhancing the editing experience. Once editing is completed, City Engine can be used to add architectural details to the mass models. Users can create animated movie files in game engines like Unity or Unreal, including dynamic elements like moving people and vehicles, making the simulation feel even more lifelike. Ladies and gentlemen, today, from understanding the city's history to visualizing its future, I encourage you to visit our documentation resource on esri.com for additional information about these 3D capabilities. Thank you.